In this video, I'm going to show you how to calculate the root mean square value of a sinusoidal voltage together with a triangular voltage. Please watch this video to the end so you understand every part of this video. Now, we have a sinusoidal voltage represented this way, and we have to find the root mean square value. Now, when you say root mean square value, how do you find the root mean square value? The first step is to identify your cycle. Once you identify your cycle, the second step is you will square the cycle. After squaring the cycle, then you find the area under the squared cycle. Then finally, you find your period and you divide by your period. Then afterwards, you do what? You take the square root of the whole expression and you are good to go. Let's see how we can use that to find our root mean square for this voltage. Now this part is a sinusoidal part, which is a half sinusoidal part. This part is a triangular, then it repeats. We can see that our period t for this part alone is equal to what? Pi. But the period for the entire cycle is what? Equal to 2 pi. Right? So once you have our period to be 2 pi, then we can go ahead and take the cycles separately. They are of different shapes, so to find the area, I need to find the area of these separately. I find the area of these separately. So now let me take the sinusoidal part. So taking the sinusoidal part, now this is the sinusoidal part. You know that our voltage is equal to Vm sine theta. You can see that this Vm here is our amplitude, the maximum voltage here. So our Vm sine what? Theta. That gives us the sinusoidal part. And now we have to square this voltage, E squared. That is going to give me Vm squared sine squared theta. Then at this point, I'm to find the area of this squared voltage. So area, and you can see that the sinusoidal part starts from 0 to pi. So I'm going to find area from 0 to pi of Vm squared sine squared theta d theta. I'm integrating this expression with respect to theta. For that reason, I'm going to bring this out because this becomes a constant. Vm squared comes out 0 to pi, then sine squared theta d theta. At this point, I'm to simplify this. And you know that when you have sine squared theta is the same as 1 minus cos squared theta over 2. So I'll replace this whole expression with this expression, then I bring my d theta. So to see that sine squared theta is equal to this, you know that cos 2a or cos 2 theta is equal to cos squared theta minus sine squared theta. So to find my sine squared theta, I'm going to this cos 2 theta. You know that my sine, I want to make sine squared theta, so sine squared theta will come here. Then my sine squared theta will be equal to cos squared theta minus what? Cos 2 theta, right? You know that this cos squared theta here is the same as 1 minus what? Sine squared theta. From the expression, sine squared theta plus cos squared theta is equal to 1. So this then minus what? Cos 2 theta. So let me start it well so you get the full understanding. So to prove that our sine squared here is equal to this, now I'm saying that cos 2 theta is equal to cos squared theta minus sine squared theta. That's an identity. Now, my sine squared theta and my cos squared theta. So cos squared theta is the same as 1 minus sine squared theta minus sine squared theta. This is this because sine squared theta plus cos squared theta is 1. Hence, when I subtract sine squared theta from 1, I should get cos squared theta. All this is equal to cos 2 theta. And at this point, I want to find my sine squared theta. My cos 2 theta will be 1 minus 2 sine squared theta. Hence, I'll get 2 sine squared theta is equal to 1 minus cos 2 theta. At this point, I'll divide through by what 2, and my sine squared theta is simply 1 minus cos 2 theta over 2. And that is why we got this. So don't be surprised. Hence, I have my Vm squared out, integral 0 to pi 1 minus cos 2 theta all over 2 d theta. At this point, this is also a constant, will come out Vm squared over 2 integral 0 to pi 1 minus cos what 2 theta d theta. Now I have my Vm squared over 2 here. Now I have integral 0 to pi of 1 minus integral 0 to pi of what? Cos 2 theta d theta. Here will give me what? Theta. Then 0 to pi is minus. Here I'm going to get 1 over 2 sine what? 2 theta. Then 0 to pi. So my Vm squared over 2 multiplying the expression. Here when 0 go here to be 0. So I get pi minus here 2. Sine 0 is 0, sine pi, so to be 2 pi, and it's also 0, so everything here will be 0. Then I'm going to get Vm squared over 2 pi as the area of the squared cycle. For my area, for my sinusoidal half parts. So now I've got my area of the square cycle here. I'm now left with the triangular aspect, which is starting from pi to 2 pi, right? So for my triangular aspect, I'm going to have, for my triangular aspect, you know that when you have a triangle and you want to find the area under it, is the line which you are interested. This line, check. So this line, and you know that the height is Vm, the length, sorry. So the y aspect is Vm, the x aspect is what? Theta. So let's see. You know that E is equal to what? So let me show you from the line equation. Y equals mx plus c. But here I will still be 0 because it is touching the x-axis. So it's complete touching, so it will still be 0. Now let's see. I'm going to have my y the same as the E. My m is what? The gradient, which is Vm over theta. Right? So let's see. I know that, so I'm going to have, let me show you here. I have my Vm here, and the distance from here to here is pi, sorry. So the gradient is Vm on what? Pi. So Vm on pi. So I'm going to have E is equal to Vm on pi. Then the x now become our theta. Now this is our what? Voltage. We have to square this and we get Vm squared over pi squared. Then I'm going to have theta what? Squared. So this is what I'm having now, and I'm going to find the area under this. So the area of what? Vm squared over pi squared theta squared d theta. Now I'm finding this area because the area starts from 0 to what? Pi, or you can say pi to 2 pi, they will be the same. So at this point, since I'm integrating with respect to theta, this will come out and I'll get Vm squared over pi squared integral 0 to pi of what? Theta squared d theta. And this is going to give me Vm squared over pi squared. Multiplying here will give me theta cubed on 3. 0 to pi. So 0, everything will be 0, then pi. I'm going to get Vm squared over pi squared, then pi cubed. So I'm going to get this place with what? Pi cubed on 3. So at this point, this pi squared will go here pi. So my answer is going to be Vm squared pi on 3. And this becomes the area of the triangular aspect, the area of the square cycle of the triangular aspect. So my total area is equal to my Vm squared pi on 3 plus the area from the sinusoidal part, which we got Vm squared pi on 2 from this side. So we got Vm squared pi on 2. So let's see. Vm squared pi on 2. So once you add these two, you are going to get 5 on 6 Vm squared pi. Once you get our total area, you know the rule is saying that once you have the total area, you are to divide this by what? Our period. And the period here is what? 2 pi. The period of the entire cycle is 2 pi. Starting from this side to this side is 2 pi. So I'm dividing. So we divide the 5 over 6 Vm squared pi by the period, which is what? 2 pi. So dividing by the period 2 pi is the same as multiplying this over what? 2 pi. So I'm going to get 1 over 2 pi 5 on 6 Vm squared pi. This pi here then tends to what? Cancel this pi here. Then I'm going to have 5 over 6 Vm squared. Then the rule is saying that our RMS value will be the square root of what we get. So 5 on 6 Vm squared. And this is going to give me Vm square root of what? So I have here was what? 2, sorry. So I had 1 over 2 here. And the 1 over 2 here will multiply the 6, making it what? 12. So here will be 12. So here will be 12. So here I'm going to get 5 on 12, and this becomes the RMS value for the whole voltage. Thank you for being with me. Please subscribe to support.